Welcome to a brief introduction to QF-Test for testing Android apps. QF-Test is a tool for automated testing of applications with graphical user interfaces. Testing Android apps has been officially introduced to QF-Test with version 6. It supports testing of native Android apps, mobile web apps or hybrid apps using the well-established QF-Test concepts. Those apps can be tested either on real or on virtual devices. Virtual devices are managed by Android Studio. However, its scope also extends to other popular UI technologies such as native Windows applications, web applications or Java applications and can be used across the board. QF-Test can also be integrated easily into existing test systems. But let me briefly show you QF-Test. You can see my demo Android app on the left and the QF-Test main window on the right. The Android app has been started in an emulator of a virtual device managed by Android Studio. Right at the beginning, it should be noted that test cases in QF-Test are displayed in a graphical tree to allow developers, test automation engineers and testers to work together on test cases without going too deep into the source code. The nodes in this graphical tree stand for individual actions such as mouse clicks or text inputs, or verification steps to check results, so-called check nodes. But also control structures such as if nodes or loops for an extended flow control are possible within QF-Test. For technically demanding cases, own code snippets can also be integrated in script nodes in different scripting languages, which also offer full access to objects of the Android app. Test cases and test steps can easily be created by capture and replay. Therefore, I start the recording mode in QF-Test. By this action, a dedicated recording window is being opened, which is technically required to gain full access to the Android app. You can even enlarge or lessen the view via the respective zoom buttons. But now we can perform the desired action within our app. I will select a table entry and press a button. After finishing the recording, either in the recording window or in QF-Test directly, I get the recently executed actions in my app as actions in the graphical tree in QF-Test as graphical nodes. And now I can rename that sequence and place the sequence to the desired position in my test case. Equally convenient is the creation of verification steps, so-called checks in QF-Test. There is a separate recording mode for this existing, which can either be triggered in the QF-Test window or in the QF-Test recording window. In order to record such checks now, I perform a right-click on the desired object in the apps view in the QF-Test recording window. And then QF-Test offers specially adapted checks for each UI element, like text and editable state for text fields, or particular checks for individual table cells like the selected state. After selecting the desired check and finishing the recording, we now receive such a check node in QF-Test, which we can rename and place accordingly in our test case. In order to minimize the maintenance efforts of test cases and in order to work within a modular structure, those sequences can be swapped out into reusable procedures. With the help of packages and procedures, sequences and test steps can be reused. For further flexibility, variables can be used at almost any point in QF-Test in order to increase the reusability and the flexibility of test suites and structures they contain. Test data, which is used, can either be managed internally or it can also be read in very easily from external data sources such as Excel files or databases. After executing a test case, you will receive a log for each execution, which shows the executed actions. It is primarily intended for error analysis. In the event of an error, you will find a meaningful error message and screenshot of the current application in the moment once the error occurs in order to analyze the situation better. For the presentation and documentation of test results, HTML overview reports can be generated manually or automatically. The test execution can also be triggered via command line and can thus be easily integrated into test management or continuous integration tools. For Jenkins, a suitable QF-Test plugin is directly available. The very stable recognition of UI controls during test execution is based on a combination of technical properties of the control itself instead of the pure geometry. QF-Test is capable of taking attributes like ID or class attributes into account. To try out QF-Test, it is the best to simply download the latest version from www.qfs.de and there switch to the download area. There you can download the current version and simply install it. You can start directly without any further action. It is also the best to apply for a 4-week test license on the download page, which allows you to save your results. In addition, you can contact our competent and helpful support team during the testing phase. QF-Test is a well-established product for automation of UI tests from Germany for 20 years. It is used by a wide range of national and international customers. It supports Java applications with Java Swing, JavaFX and Eclipse SWT, native Windows applications and web applications including modern frameworks like Angular, React or Vue.js. Hybrid applications with embedded browsers, especially WebView and JX browsers, or systems that display Java in the browser, such as WebSwing or JPro, and also Electron applications can be easily controlled. A new addition is the support of Android apps in emulators or on real devices. All this is possible across Windows, Linux and Mac OS operating systems. Just try it out yourself or arrange a starter webinar where we will be happy to answer your specific topics and questions. We look forward to hearing back from you. If you want to keep up to date about the latest news and tutorials, don't miss to subscribe to our channel.